Advanced Algebra 2, Concept 15, Synthetic Division and the Remainder Theorem. So let's continue our work with polynomials. So synthetic division is a shortcut method to divide a polynomial by a linear binomial in the form x minus k, where k is the value used in the method. So k is actually the opposite sign of what you see. So if you see x minus 2, then the k value is 2. So this same method can be used to evaluate a polynomial for a given value, and it's called synthetic substitution, which you have already learned. So we're using a process that you know, but to give you a different answer. So number 1 says divide negative x cubed plus 4x squared plus 9 by x minus 3. So the first is the dividend and the second is the divisor. So we can use synthetic substitution, but we're going to use it for division. So the first thing we do is our dividend, what we're dividing, we're going to pull those coefficients and put them in our space. So we have negative 1, 4, and then the 0 placeholder for our x term, 9. And then notice we're dividing by x minus 3. So the number that goes out to the side, the k value, is actually 3. Then we're going to use that process that we've learned where we bring down our first number, we multiply diagonally, and then add vertically. Now, step 3 says multiply the previous sum by the x value, which we've done, write the product under the third coefficient, add and repeat, which we did. But look at the last sentence. So the last two sentences, the last number is the remainder, and then the rest of the numbers in the bottom row are the coefficients of the quotient starting with 1 degree less than the dividend. So notice we were dividing an x cubed by an x. So if we look up top, x cubed divided by a single x is x squared. So that means our numbers along our bottom in our synthetic division, those are our coefficients of the polynomial negative 1x squared plus, because that's a positive 1, 1x, and then plus, because it's a positive 3 with a remainder of 18. And we'll put our remainder over our divisor, x minus 3. Now another way to write that, and this is our quotient, is negative x squared plus x plus 3, and then remainder 18. So that's probably how Math Excel will ask you to enter it. And so this right here is the polynomial quotient when you take that original cubic, negative x cubed plus 4x squared plus 9, and divide it by x minus 3. So look at number 2. This says divide using synthetic division. So we're going to divide that quadratic by that linear. So we're going to pull the coefficients of 1, 8, and 1, and then put our k value, which will be positive 4, out to the side. So we do our synthetic division process now. And then we're going to place our variables. So x squared divided by a single x is x, just a single x. So our first term will have a coefficient of 1 and then an x, and then plus 12 with the remainder of positive 49 over x minus 4. We can also write that as x plus 12, remainder 49. So notice when we list it as a remainder, we don't include that divisor with it. Number 3, let's do another division problem. So we're dividing this cubic by this linear. So we're going to pull off our coefficients. Notice we're missing an x squared term, so we put the 0 placeholder in. And x plus 3, notice our k value will be the negative 3. So we use our synthetic division process, multiply diagonally, and add vertically. And now we're going to write our quotient by putting in our variables. So x cubed divided by x to the first power is x squared. So we'll start with our x squared term. So 1x squared minus 3x plus 5, and then minus 9 over x plus 3. So just rewriting that, x squared minus 3x plus 5 minus 9 over x plus 3. And you know it can also be written as x squared minus 3x plus 5 with a remainder of -9. So that's how we use the synthetic division process to give us a polynomial that's a quotient when we divide one polynomial by another. So in synthetic division, you know that the remainder, or the last number in the bottom row, is also what you would get if you substituted k into the function. So that's what we did in concept 13. And that's what the remainder theorem says, that f of k is the remainder. More importantly, you can determine if a linear expression x minus k is a factor of a polynomial if it divides evenly into it, and that means your remainder, your last number in the synthetic division process, will be 0. So we have one process, the synthetic substitution or division, and it will tell us 3 different things. So the remainder theorem says that f of k, if it equals 0, then x minus k is a factor. All right, let's do what I'm talking about. So first we have the directions use synthetic division and the remainder theorem to find p of a. So that just simply means the value of the function when we plug in a number for a. And here we're plugging in -5. So we're going to pull off the coefficients. Notice that we're missing an x squared term, so we'll put in a 0 placeholder. And then since we're just plugging in the value of -5, that's the value we use. Then we do the synthetic division process, so we bring down our 1 and then multiply diagonally and add vertically. Now we're going to look at our last number, which is our remainder, and we want to know what p of a, or in this case p of -5, equals, and that will be 10, our remainder in our synthetic division process. And that's what the remainder theorem says. So now number 5, we want to find the value of this quadratic when a equals 2. So we'll pull our coefficients off, put 2 out, and then bring down our 4 and multiply, and then add and multiply and add. And we're looking at our last number, our remainder. So p of x, or in this case, I should say a, or 2, p of 2 should equal -15. Now we're going to use the same process and the idea of the remainder theorem to determine whether that first polynomial, so x plus 3, is a factor, meaning it divides evenly. So again, we'll do the same process of this synthetic division. Our k value is now -3, because remember, when it's in an expression, it's the opposite sign. So I start by bringing down 1, multiplying by -3, add, which is 1, -3, -12. So now if I look at my remainder, my last number, it is 0. So that means that x plus 3 divided evenly into this cubic function. So it definitely is a factor. So since our remainder is 0, then x plus 3 is a factor. If that remainder had been a number other than 0, then it would not be a factor. Okay, so let's do the same thing. Let's determine whether x minus 2 is a factor of this quadratic. So we'll pull off our coefficients. Notice our k value is +2. So we'll start by bringing down 1 and then multiplying diagonally 2, adding, which is 1, multiplying by 2 and adding. So our remainder is -1. So what that means is that binomial x minus 2 is not a factor, so it did not divide evenly. So our remainder is -1, so x minus 2 is not a factor. All right, this concludes the concept 15 notes. So again, using that same process, you learned it in concept 13 as synthetic substitution, but now we call it synthetic division. So synthetic, it can be used to evaluate a polynomial, to find, for example, p of 2 for a polynomial p. It can be used to find a quotient, so when you take one polynomial and divide by another, and then it can also be used to determine if one polynomial is a factor of the other.